In our last lecture, we were discussing number system. Today, we'll see how to convert from one number system to another number system. So we'll start with the topic that is number system conversion. For example, if we want to express our number in binary, suppose we want to express the number using 2-bit binary number. So the first number in binary is 00 for 2-bit case. The next number will be 01. And in binary we have only two symbols, 0 and 1. So as I have written 01 here, what will be the next number? Next number will be 10 because we do not have any other symbol. And what is the next number? That is 11. Now if we convert this to decimal, suppose this is binary, we want to convert this number to decimal. We know this 00 represents the decimal value of 0. 01 represents the decimal value, the next number is 1. The next number in binary is 10, where the next number in decimal is 2, and 11 is 3. We have figured it out by counting. But what is the general rule? First of all, we'll learn to convert from base R, that means any base system, to decimal system. Decimal number. So this is the conversion we'll learn at the very beginning. So any base R system to decimal number system. Suppose the general equation for representing any number, that is a n minus 1, a n minus 2. So in this way it will continue, and this n value will be reduced, and a1, a0. And if we have fraction, then the fractional part can be represented by a minus 1, then a minus 2. In this way, if we keep going, it will go up to a minus m plus 1. Finally, it will go up to minus m. This 0, 1, n minus 2, n minus 1 represents the position of the integer. And minus 1, minus 2, minus m plus 1, and minus m, these are the positions of the fractional portion. For example, if we have a number 97.65, and this is a decimal number. So here, this is our a0, this is a1. We have values up to a1, and this is a minus 1, and this is a minus 2 value. If we have a number 653.25, and this is an octal number, so here a0 is this is a1, this is a2, and this is a minus 1, and this a minus 2. So this is the general way of representing any number. So if we want to get from any base number system to decimal number system, or if we want to convert from base or system to decimal number system, the general equation will be number in decimal equal to summation of ai r to the power I. Here r is the base, and I equal to 0 to I equal to n minus 1. This is the integer part. And if we have fractional portion, that will have summation of aj r to the power j, j equal to minus m to j equal to minus 1, and this portion is the fractional portion, fractional part. Let's see an example, then things will be clear to all of us. Suppose we want to convert a binary number 101 to decimal. So what is the value of 101 binary in decimal? Here this is A0, this is A1, and this is A2. We do not have any fractional portion, so we do not need to utilize this portion. So if we employ this, then the number in decimal can be written as A2 R square, we are starting from here, plus A1 R1 plus A0 R to the power 0. Here base R equal to 2. We can see the base R equal to 2, so we are putting R equal to 2. So if we put the values, what is the value of A2? A2 equal to 1. 1 into 2 square plus, what is the value of A1? A1 equal to 0. So 0 into 2 to the power 1 plus 1 into 2 to the power 0. So the value becomes 4 plus 1 is equal to 5. So the decimal equivalent of 101 binary is 5. Now let us see another example with fractional part. So let's see another example. Here we had the first example. Now we want to convert this number to D3.5. We have fractional part. This is hexadecimal number. What is the corresponding value in decimal? Here we have integer part and the fractional part. This 3 is our A0, this D A1, and this 2 A2, and this 5 is our A minus 1. Only one digit is available in the fractional part. So the decimal number is equal to A2 R to the power 2 plus A1 R to the power 1 plus A0 R to the power 0 plus, we need to write this fractional part, A minus 1 R to the power minus 1. That's it. What is the value of radius or base here? The value of base equal to 16. This is hexadecimal number. So we'll put all these values. A2 equal to 2 into 16 square plus D into 16 to the power 1 plus 3 into 16 to the power 0 plus 5 into 16 to the power minus 1. Now, what is the value of D here? As we are converting from hexadecimal number to decimal number, all these notations are to be converted to corresponding decimal number. We know the corresponding decimal number for D is 13. So let's rewrite this line, 2 into 16 square plus 13 into 16 plus 3 into 16 plus 5 into 16 to the power minus 1. If we calculate it using calculator, we'll get the value equal to 723.3125. This is in decimal. The decimal equivalent of this hexadecimal number to the 3.5 is equal to 723.3125. This is the result. I hope the concept is clear to all of you. Now, if you are given any base number system, then I hope you will be able to convert that base number system to decimal number system, employing this equation. I am giving you a task which you may solve for your practice. Convert this Maya number, that means the number used by the Mayan civilizations. We have this symbol, point. This is a Mayan number. We know Mayan number has 30 base. So from 30 base to decimal number, what is the corresponding value in decimal? This portion is integer and this portion is fractional. Try to solve this task. To know the corresponding decimal value of each Maya symbol, you may use this chart. You can see each symbol has corresponding decimal value, which is shown here. Till now, we have learned how to convert any R-base number system to decimal number system. Now we will see how to convert a decimal number to any R-base number system. We'll see the conversion of decimal number to any base R system. We know the decimal number has two parts. One is integer part and another is fractional part. Conversion of integer part is done by successive division. It means, or it involves, dividing repeatedly by the number of the base to which you are converting. Continue the process until the answer is 0. Here we need to keep the record of the remainder at each stage. Now, how to convert the fractional part? For the fractional part, we need to employ the successive multiplying. It involves multiplying the fractional part of the decimal number by the number of base to which you are converting, and record the carry. Let's see some examples, then the process will be clear to all of you. Suppose we want to find the binary equivalent of this decimal number 13.375. This is decimal. What is the equivalent value in binary? We can see we have two parts. One is integer part, that is 13. Another is fractional part, that is 0.375. We can see for the integer part, we should go for successive division by the base to which we want to convert. So we have the base, targeting base is 2, because we want to convert the number to binary digit. We need to go for successive division of the integer part by this base, that means 2. So let's start. We'll write 13, divide it by 2. First dividend is 6, that means 6 into 2 is 12. So we have one remainder. We need to keep dividing until we get 0. So again it's 3. So 3 into 2 is 6. So the remainder will be 0. Again 2 will get 1. The remainder is 1. Finally, if we divide it by 2, then the result will be 0. So no need to do it. And the writing order will be like this. What does it mean? This 1 is MSB, most significant bit, and this one is LSB, least significant bit. So the binary equivalent of 13 decimal is, this is MSB, so 1 1 0 1. This is the binary equivalent of 13. So this portion is over. Now we will go for the fractional part. For fractional part, we need to go for successive multiplying. We need to multiply this value by the base number to which we want to convert. So here we want to convert this number to decimal. We need to multiply this 0.375 by 2, and we need to keep the record of the carry. So if we write here, we are coming from here to here. 0.375 into 2 is equal to 0.75. Here carry is 0. So let's write the carry here. Carry is 0. We should keep multiplying this value until we get the result equal to 0. So 0.75 into 2, the value becomes 1.5. So here we have carry 1, and this is the fractional part. So let's separate this carry part, this 1, and the fractional part will write again 0.50, and we should multiply it by 2. That is equal to 1.00. We have carry 1 and the fractional part is 00. So let's separate the carry part. So carry 1, and we have 00. No need to multiply 0 with 2, we'll get 0. So we end here. We can write the binary equivalent of 0.375 decimal is equal to, this will be the order, which means this is MSB and this is LSB. So the value will be 0.011. Let's set 0.011. Hence, finally, we can write the binary equivalent of 13.375 decimal number is equal to this value 1101.011, and this is the final result. Here we need to put 2. Now let us see another example. Suppose we want to convert this decimal number 73.75 to octal number having 8 base. Process is similar as mentioned earlier. This is the integer part and this is the fractional part. Let's deal with the integer part first. For the integer part, we need to go for successive division by which value? By the base value to which we are going to convert. So here we want to convert this number, this decimal number, to octal number. So 73, we should divide this number, the integer part, by 8. The result will be 9. 9 into 8 gives us 72, and the remainder is 1. Again, let's keep dividing by 8. It's 1, and we have remainder equal to 1. And we can divide this 1 by 8 again. We can do it or we may ignore it. Let's show it to you. 8, then the result will be 0 and the remainder will be 1. So this 1 will come here. So the writing order will be like this. What does it mean? This value is MSB, LSB. Hence we can say the octal equivalent of 73 decimal is 111. Though we have 111 here, but it's not binary, it's octal number. For this particular example, we are getting 111. Now let's solve the fractional part. For the fractional part, we need to multiply 0.75 by the base 8. The result we get 6.00. If we write the carry separately, so the carry is 6. The 6 is here. No need to multiply this 00 with 8. We will get zeros, so we are not writing. We can write 0.75 decimal is equal to 0.6 in octal. So we can say 73.75 decimal is equal to 111.6 in octal. I hope the process is clear to all of you. Let's see another example where we will convert a decimal number to hexadecimal system. Suppose we want to convert 2545.342 decimal to hexadecimal. Here we have integer part and fractional part. Let's deal with integer part first. 2545. As our targeting base is 16, so we need to go for successive division by 16. The first result is 159 and the remainder is 1. You may use calculator for this calculation. Next, again divide this number by 16. The result is 9 and the remainder is 50. As this 9 value is less than 16, we can divide this 9 by 16, will get 0 and 9 will be here, or we can ignore that. So the writing order will be like this. Here 9 is MSB and 1 is LSB. So let's write the portion here. We are going from here to here. We can write 2545 decimal is equal to 9, 15, 1. Now we can say we have 15 here. That means in decimal we are utilizing 1 and 5 here, but for hexadecimal number this 15 is represented by a single symbol. What is that? That is F. As we are converting to hexadecimal number, so this 15 should be written in this unique symbol from that is the symbol used in hexadecimal number. So 9F1 will be the hexadecimal equivalent number of this 2545 decimal number. Finally, let us deal with the fractional part, which is 0.342, and let's keep multiplying this number by 16. First, the result is 5.472. The carry, if we take it out, then 5 will be here and the fractional part can be brought here 0.472. which should be multiplied again by 16, and that will give us the result, which is 7.552. Again, if we separate the carry, 7 will be taken out and the remaining part 0.552. Again, this number should be multiplied by 16, which is the targeted base, and that will give us the result 8.832. We can take 8 out, and finally we can write 0.832 into 16. We are getting 13.312, and this 13 should be taken out. And as we are converting this number to hexadecimal number, so instead of writing 13, we have unique symbol in hexadecimal number, that is D for 13. We can write D here. Well, we can go many more multiplications to improve the accuracy of the conversion. But for this type of case, we can write 0.342, which is in decimal, is almost equivalent to 0.57D in hexadecimal number. This will be the order of writing. It's an approximation. However, you can go on many more multiplications to improve the accuracy of the conversion. So we can write 2545.342 decimal is equivalent to 9FL.57D. We can write some dots here. We can have some more values in hexadecimal. Oh, here 18 is missing. It's 0.578T. 57. I missed 8 here. Here there will be 8 in D. We are concluding here. We will continue in the next lecture.